Hi everyone, welcome and thanks for joining this webinar with OpenIO. The topic of the day is about running apps directly on the storage infrastructure. I am Mary Poncel, co-founder and VP of Marketing at OpenIO. Few points before we start. This webinar is recorded. We'll send you the link to the video after the presentation. If you have any question or feedback, feel free to ask them at any time. We'll be happy to answer at the end of the presentation. I'm happy to introduce our two speakers, Enrico Signoretti, Head of Product Strategy at OpenIO. Welcome, Enrico.
Welcome and good morning or good evening to everyone.
Welcome, Enrico. And Guillaume Delaporte, co-founder and Head of Pre-Sales at OpenIO. Welcome, Guillaume.
Hi, welcome everybody. I'm very glad to start this webinar because we will showcase today a very unique and exciting features about OpenIO. So I'm very happy to do it today.
Thank you, Guillaume. So the agenda is divided in 4 parts. First, we'll make a quick introduction about the computing models and their evolution. Then we'll introduce Grid4Apps, our serverless data processing technology, which is able to run applications directly on the storage store. We'll then detail how does Grid4Apps work, and we'll demonstrate a very nice demo using Grid4Apps and TensorFlow. TensorFlow is the open source software library for machine learning developed by Google. And at the end, we'll conclude the webinar by talking about the future of Grid4Apps. No more talking on my side. Enrico, I'll let you introduce the first point.
Okay, thank you very much, Marie. So let me introduce again OpenIO in case you are not familiar with our company and our history. I will be very quick on this. So the company is very, very young. We started in 2015 and we're planning a global launch for 2017. But actually, the product, the core technology is very mature and robust because we started the development of the product in 2007. In 2009, we had our first production with 1 petabyte, and then 2012 we open sourced the product, and in 2014 the first installation reached 15 petabyte in a single domain. So we have offices in Lille, San Francisco, and Tokyo, and we are planning to further expansion in US with offices in Washington DC later this year. What we do, we just do next generation object storage, plus we have an integrated framework for data processing, okay, based on events. So it's important to know that we are entering in the data-centric era, and the approach of our company to the data-centric era is object storage, of course. So we can scale from 1 disk to hundreds or petabytes and trillion of objects. We have a specific technology that helps you to scale the cluster indefinitely and without any pain. We tackle the reduction of the TCO by using commodity hardware and open source software, and on top of it we have this event-driven data processing framework that allows to run application directly into the storage infrastructure. And if we look at the market today, okay, the market is split in two. On one side we have latency focused application, so everything that it's really latency sensitive, so high frequency modification, transaction, databases, for example, okay, a lot of IOPS, low latency and consistent latency, of course, and most of the solutions are hardware based. On the other side, we can see that there are a lot of unstructured data, okay, and a capacity that is growing very quickly, and this kind of data is characterized by lower frequency modification. Some of the data is really mutable, but we need a lot of bandwidth and price per gigabyte. Okay, most of the solutions are software based and they are running on commodity hardware. The use cases that we tackle with our solution are all of the traditional use cases that you can find in the object storage, okay, so email, platform, media and entertainment, private cloud storage, enterprise object and cloud storage, backup and archiving, and big data. Everything that is big and small in terms of data, and everything that is as a workload ranges from a lot of small transaction to large files downloaded. Okay, at the same time, because our technology, we can target different use cases that we usually define as next generation applications, and they include integrated data processing, industrial Internet of Things, as well as machine learning. So what does data-centric here mean? On one side, you have all this unstructured data, okay, photos, movies, whatever we are creating and we are storing on our system. Okay, this is a huge amount of data, but actually it's not only that. Okay, we are seeing a growth in everything that is machine generated. Okay, logs from computers in the data center, for example, or if we look at what the enterprises are doing, they are creating big data lakes. So they are storing everything for a very long time. Sometimes they don't have a big data strategy yet, but just because they could have it in the future, they are just storing data. And at the same time, there is a huge impact in the market from industrial IoT. Okay, we are seeing the first project now, but actually the amount of data that this kind of sensor can create, million of sensors together can create, is amazing. And then there is machine learning and artificial intelligence. This is the next wave. Okay, most of these applications are based on data, so they are just to oversimplify maybe, but actually most of these applications, they look for patterns in huge amounts of data, and they are trying to recognize a pattern in files, and they try to reproduce that kind of pattern. So actually it's very important to have the application next to the data. In fact, if you look at what is happening in the whole industry, we are starting again to talk about edge computing. Okay, so we talked about cloud computing for years, but actually now there are a lot of new kind of infrastructure. Think about a car. A car has a lot of CPU power, have storage, and all the sensors are connected together. Okay, but it could be also an offshore platform. Anything that need some compute power, that stores data, collects data from sensor, need some CPU to do the compute of this data. Okay, and they are not close to the data center. Okay, they are not close to the cloud. In fact, it could happen that, for example, if you think about this next generation application again, okay, it's very important to have data close to the application. Think about this picture. Okay, this is just an example. The idea here is that you can arrive at an airport. Okay, camera takes picture, and they recognize that you are a female or male, and you are dressing a particular type of shirt and jeans and whatever. So the signs change in the airport and they send you to the particular shop or to the particular restaurant, because it's more likely that you will spend money there than in another one. Okay, and to do that, you need to be very, very reactive. Okay, the time that passes from the moment the camera takes a picture and the sign changes is very, very short, and for a very small amount of time, because it's for you. So if you do this using the cloud, this is impossible, because just the time you take the picture, you send the picture to the cloud, and you get the result back, and you do the changes. So you pass the sign, and and the advertisement doesn't work. Okay, so you need for this kind of application, you need data close to the application. If you look at the market and how it is evolving, okay, there is an important evolution. We saw virtualization at the beginning of the 2000s, and it was great. Okay, so it was a lot about consolidation, not consolidating one machine in 10 machines in one, 20 in one, 30 in one, whatever. And then we saw Amazon EC2, which is almost the same concept, but on the cloud. Okay, and when VMware was the leader, or is the leader in when we are talking on premises. Okay, but now that we have thousands of these machines, managing them becomes really complicated, especially for the next generation applications. So we are looking at containers, okay, stateless computing, and it is very good. And you can again find examples both in the cloud and on premises. The problem with the containers is that storage persistency is not the focus of this kind of application. Okay, and if you look at most of the solutions that are already present in the market, they are not really successful because they don't usually target the real problem with the containers. Now, lately, we have serverless computing. Okay, I really hate the buzzword, but actually it means that you don't need to manage anything in the middle between your code and the storage system. So you have Amazon with Lambda over S3, for example, okay, or in our case, OpenIO. So we are very similar to Amazon Lambda, or at least the concept is very similar, and we can run code directly into your storage system. This is very powerful. Of course, it's not for all use cases. Okay, you can't run SAP, for example, in OpenIO, but actually there are many tasks that can be offloaded to the storage, and we'll talk about this later. The same thing is happening on the hardware side. Okay, we started with Intel CPUs. The data centers are full of Intel CPUs. Okay, and they are good. They are good for any sort of general purpose workload. The problem is that they are not efficient for Internet of Things, as well as power efficient. Okay, so harm started to appear in the data center, and probably you saw that, for example, Microsoft in its data center is going to adopt a huge number of ARM servers and coprocessor. Okay, now most of the cloud providers are offering not only x86 CPUs, but also GPUs, FPGAs, and other similar coprocessor, okay, to speed up specific operation, like, for example, video transcoding or internet or streaming or artificial intelligence. So we are not just another object store. Okay, we think we are different, and there are several reasons because we are different. The first reason is that we have a very lightweight design. Okay, it means that our core product can run on a ARM core, a single ARM core, not a single CPU, just a core in an ARM CPU, and with 500 megabytes of RAM. Okay, so it's very light, and this means two things. One is that we can run in a very large data center. Okay, think about x86 computer with 60 or 90 disks, for example, and many of them in multi-petabyte clusters, as well as in very small $5 computers like the Raspberry Pi. Okay, and this allowed us to build a specific hardware component, okay, that we use to showcase the technology at the moment. And the idea is that just by plugging a small PCB in front of the disk, we can obtain what we call a nanonode. So each single disk is a nanonode, and the nanonode comes with Ethernet connections, RAM, SSD inside, and of course an hard disk. And it has the file domain is very, very small. Okay, one disk, and which is the best that you can have in the industry today. And at the same time, the performance is very high because each single node is responsible for the data of a single disk. So the parallelism is very high. The other thing is that flexibility. Okay, so because the technology we implement, especially what we call conscious technology, so we have the ability to run our cluster on a heterogeneous node. So it means that we can run a cluster that has x86 machines, flash, and SATA disk in the same machines, ARM CPUs as well as GPUs. Okay, and we can choose the best resource for each single operation in real time. And at the end, we have this integrated data processing framework. Okay, the difference with the rest of the market is that, of course, we can run application directly into the storage system, and it helps you to offload a lot of information, a lot of tasks. For example, data filtering or pattern matching. For each object, you can check if there is a virus, or if there is, if you are storing credit card number and you shouldn't, or whatever, or as we will see later, face recognition, or anything else. So why we think we are beyond object storage? Because if you look at the market, if you take all the competitors in the market, you will see that most of them, all of them, are now able to tackle traditional object store workload. At the same time, they provide scale-out storage, S3 and Swift protocol. So it's a table stake today. And some of them went further, and they started to target big data applications, but actually they do only a little bit of search and index, so a few analytics functions, and they can provide HDFS interface. Okay, it's not enough. We can do much more, because we can run the big data directly into the system. For example, we can provide through the event-driven framework, data normalization when the data comes in. We can check if the object is well formed. For example, if it comes from an IoT device, you would like to check if everything is coming with in the right format, in the right way. Okay, and of course we will see later how it applies to machine learning. So again, we can call it serverless, but actually also ultra convergent, if I can use a new buzzword here. And it's just data plus application. You don't need anything else. If you think about a potential architecture, okay, you can have OpenIO in the data center, replicate the data between the data center. Okay, OpenIO is here, and this is the role that it has in many of our customers. But actually, you could have connected cars, and the connected cars could have ARM CPUs inside, and they, just because the same technology, it is the same identical technology, so you can use OpenIO in the connected car to do some computation, collect data, save data in an high availability and very resilient mode, and then you can have the same on as I mentioned before, on a remote site, and then you can replicate data. Okay, you can build end-to-end data plane with compute for any sort of data. So this is why this is the perfect backend for next generation application. No matter if it is Internet of Things, no matter if it is video transcoding, no matter if it is big data applications. And it's of course the best for efficiency. So because we have this technology that can run in a single core CPU, and you can just think about how many cores your server have, 8, 16, maybe more. So we are not actually using all of these cores for our system. Okay, even if we are doing erasure coding, for example, we use a little quantity of resources. So the rest of the resources are free, and you can use them to run the applications. And it's a powerful way to improve the efficiency of the whole infrastructure. So look at the market for general purpose hyperconvergence. If you look at it, you will see that general purpose hyperconvergence is good if the workload that you're running on it is on average. So if you think about VMware, okay, for example, VMware is not a workload, but the sum of all the machines inside a VMware environment, they produce a sort of very well balanced sort of workload, because you have databases, you have mail server, you have a web server, you have many different applications, and the sum of them create something that is you know, really predictable at the end. So you can keep adding more and more nodes, and they are very similar. But actually, if you're looking at big data application, for example, just to mention one, you see that you can't do that with the traditional hyperconvergence because it's not efficient enough. Okay, hyperconvergence is very simple to implement and to use, but actually it's not really efficient. It's simple. Well, if you want the very optimized infrastructure, you go to a specialized hyperconvergence. Or if you want the best of breed in terms of latency, you still go to all-flash storage today, okay, for enterprise application. But if you need even more, okay, high-speed transaction, for example, in the finance, you can go to in-memory storage on this side. On the other side, if you have a lot of capacity and you want to use some of the CPU to run the application, you can do a Lambda-like serverless enabled storage. Okay, so you can run the function directly into the storage system. We are here, actually, we are positioned here, and we are going towards this direction. So if you look at the traditional computing models, just to explain better what you have in mind, and you look at all the layers that you usually have in a traditional computing system. So you will find data storage, hypervisor, operating system, containers, now orchestration layers, and application. It's complex. Okay, well, I don't need that everything can be removed, but actually if you have the right application, you can do everything just with data storage and the application. Okay, which is much easier to manage, and it is much efficient because you don't need anything else. So the storage system creates events. Everything that is a read, a write, an update of an object, whatever, creates an event. And that is intercepted, and it triggers an application. As easy as this.
Thanks a lot, Enrico. If you guys have some questions about the first part of the presentation, feel free to send your question in the app. We'll tackle them at the end of the presentation. So Guillaume is now going to take the second part of this presentation. Please go ahead, Guillaume.
Thank you, Mary. Thank you, Enrico. So first of all, I wanted to mention something, because for those who are already familiar with OpenIO, I wanted to say that we will showcase a brand new feature of OpenIO, something really unique on the market. But first of all, it's still OpenIO. I mean, it's still our software-defined storage solution, our object storage solution. So the solution is still made to store petabytes and thousands of petabytes of data, billions of objects. It's still a solution that is able to protect the data, so we have replication and erasure coding. It's still also a solution that is able to serve the data using Swift APIs, S3 APIs. We have also native APIs or Files API. So the processing I will showcase right after about processing of the data, the Grid for Apps technology, is another brick in the OpenIO SDS software. It's not something different. It's really something integrated in the solution to enable new use cases. So again, we made a webinar 1 or 2 months ago, and it was about our object storage solution. So it's still the same thing. I will not take too much time on it. If you want to have more information about it, you can check the previous webinar. We have the videos on our website, but it's still the OpenIO solution with the conscious technologies that is able to compute a quality score on every disk of the platform, to do real-time load balancing, data placement, and we have still all our good points about our object storage solution, and we are adding the Grid for Apps on top of it. So about the demo, to explain how works our Grid for Apps technology, it's an event-driven data processing framework. So when you are uploading an object, a file inside our object storage solution, so let's say you are using the S3 API, so you are uploading a new file. What will happen in the solution, in the platform? It will pop, an event will pop inside OpenIO and will put it in a queue manager. So for example, you have a new object, you delete an object, you have a new metadata, so you will have an event for that. At the end, you can build and code your own script that will listen on this queue manager, and every time there is a new event, like, okay, there is a new file, you can take this event and say, okay, I want to do something on this new object uploaded. So it could be processing of a video, I mean transcoding of video for a video use case, like, okay, I want a different format of my video. It could be antivirus, I mean you have a new file that is uploaded and you want to check if the file is safe. It could be indexation of email. Really, you can build your own script, so you can do whatever you want. And at the end, with this script, it could be you could do some derivative content. So if we are thinking about the video and the transcoding of video, you can have derivative videos, and then you can upload it again inside OpenIO. So at the end, you will have the source file and then many different derivative content from this first video, and it could be enriching of metadata. It could be everything you want. And let's take an example, and this is the one I will showcase during the demo. Let's say that you are uploading a new picture, a picture of a volcano. So the file will be uploaded inside OpenIO. Again, it will be secured using replication or erasure coding. You will have access to it using Swift or S3 APIs or the OpenIO APIs. And then when you upload this picture, you will have an event that, okay, there is a new content inside OpenIO. Then during the demo, and I will show you the code, we built a script using the TensorFlow APIs and the Elasticsearch APIs. So the script will take the object, launch TensorFlow on it to detect if it's a volcano, if it's a dog, if it's shoes, and we will put a new metadata on this object. So it's a picture, and the new metadata is category is equal to volcano. And then we'll enrich the object with this new metadata. And for this demo, we'll just to show you that we can build more complex use case, we will also index the metadata inside Elasticsearch. So at the end, we'll be able to say also, if you think about a use case with billions of pictures, say, okay, give me all the pictures where the category is equal to volcano. So it will highlight all the object with this specific metadata. So okay, let's go to the demo. So for the demo, we just to mention it, we will use the OpenIO browser, which is a side project inside OpenIO. You have the code here on GitHub. So if you want to use it, you can. It's just the OpenIO browser. It's just a web user interface on top of OpenIO using the OpenIO APIs. It's just a convenient way to show the picture and to show the metadata more than using also only CLI. And just to mention it, we use TensorFlow, which is an open source solution, an open source software, and we'll use it to process the picture and to say, okay, this is a dog, this is a volcano, this is just to analyze the picture and to say that we can be sure that in this picture you have a dog. So let's go to the platform, the demo platform. First of all, I will not explain everything about that, but just to mention it, here you can see that we have different handler and different event. I mean that you can see in this file that you can do some event on when you upload a new content, but it could be also when you add the metadata, when you delete the content, when you create a container. So I will not go into details in every event, but just keep in mind that you can really build this event-driven processing framework, and you can use it in very different way, not only when you upload a file. It could be also when you add a new metadata on a file. And about the script that we will use, so this is a script that we have written for this webinar. I will not, again, explain everything. So the first couple of lines are only about TensorFlow, all the function of TensorFlow that you can find in the website of TensorFlow. But here you can see that this is the main part of the script. So we will listen on the queue manager, which has been stocked in this demo, and then we will here download the object. So we will, okay, there is a new object, so we will download the object. We will process it using TensorFlow here, and at the end we will re-upload and we'll enrich the data with new metadata with the category of the picture, and at the end we'll upload the metadata inside Elasticsearch, and at the end we'll delete the job. So, and for the search, it's just to say at the end, okay, I want all the picture where we can see a dog inside. So this is a use case. If you, just to mention it, if you go to our website, in the blog section, you have a different blog post about the grid for apps. So we have one about a very introduction to grid for apps. We have one about Elasticsearch, what we will use in this demo. And I will publish today a blog post about how to recognize face in pictures. So it was one of the slides from Enrico. I mean, you can detect that in this picture you have 10 faces, and they are located here, here, and here. So I will upload it today, and we will also, just because I was very fast on the script, don't need to take a screenshot of the script. We will upload all the content of this demo on our blog post, so you will be able at the end to do the same by yourself. So okay, so let's upload some file using our OpenIO browser web interface. So I can upload some file here. So it's just a couple of pictures, and I will upload them on the OpenIO browser, and you will see that we'll upload the file inside OpenIO, and in the background, the script with TensorFlow will run and detect patterns inside the pictures. So let's upload it. So you can see that here the file are uploaded, and you can see that in the category section, we can see that some metadata are appearing here. So let's wait. So okay, one last here. And so you can see now that while I was uploading the file in the background, the TensorFlow script was launched, and we have now in the category section some information about the picture I just uploaded. So you can see that here it's a hard disk with a confidence. So we can be sure that at 98% that this is hard drive. This is a banana at 99%. So like I explained you, we enrich the data with new metadata coming from the TensorFlow, the script that use the TensorFlow APIs. And also you have here a search box, and we will use it to find and to request from Elasticsearch some pictures where we can find, for example, as OpenIO is a French company at the very beginning, French, where you can find French loaf in a picture. So you can see that here using this search box, it asked to Elasticsearch give me all the picture where I can find a French loaf inside. And it could be, if it's for the dog, a golden, so you can ask for a golden, and it highlights at the end, you have all the pictures where you can see a golden retriever. So this is the end of this demo. It's again, I will publish everything on the blog, so you will be able to do it by yourself, but it's a way to explain how you can, with OpenIO, store data at scale and also launch processing of on data at scale. Here it's TensorFlow with Elasticsearch, but you can think there is many use cases that you can implement on top of that about security, like antivirus, about processing of videos, of pictures, and we have many different use cases that you can implement. At the end, you can write your own script, so you can really do the processing that match to your use case.
Thank you very much, Guillaume.
Oh, you're welcome. And if you have any question, feel free to ask in the question section, and I will tackle them at the end.
Yes, I think Enrico has the last part about the future of Grid for Apps. Please go ahead, Enrico.
Yes, I have just a couple of more slides to show you, first of all, how we propose our software. Okay, so the OpenIO core SDS core is licensed with the AGPL license, and it's available online, as well as the S3 and Swift gateways, and Grid for Apps, which is the product that we used for this demo, is available also in the same distribution. Okay, all the other components are sold separately. Okay, so the web user interface is part of our support contracts, and as well as the deployment tools, Grid for Apps, Pro, mail connectors, and file gateways. What is really important here, that it's everything that you saw in the demo is possible with the open source version. What we are going to do in the next few months is an improvement of Grid for Apps, which is not yet announced. Okay, we will be able to run full-fledged containers in the system, and the scheduler will be more sophisticated than what is available now. So there will be an agent on each single node that will communicate with the scheduler, and the idea is that containers will be downloaded from each single node, and they will be always available. So to speed up compute when a script is needed, and to simplify the software distribution to the nodes. And at the same time, we will add a user interface that will allow you to monitor the state of the cluster and other functions that are available. In a future release, we will also implement the same identical feature that you can have from Amazon and Amazon-like services, so functions. So it will be able to just copy and paste your code in a UI, and you will be able to run your application without doing editing of the script and distribute the script on the nodes. So it will become very powerful, even for users that are not planning to distribute a complex application and with libraries and with other stuff. So this is what is going to happen in the very near future for this project. So we are investing a lot in it, and we think this is a great differentiator for our platform. I think that with this slide I have finished, and so we are here for the questions now.
Yeah, thanks a lot, Enrico. I take the first question, maybe for Guillaume. In which language can we write the scripts?
So this is a good question. So as I told you, you can write your own script, and The script, the only goal of this script is to listen on a queue manager which has been stocked and so if you use a language that is able to run on Linux distribution and is able to talk with the beanstalk queue manager, you can write it in the language you prefer. I mean, you can write it in Java, in Python. In the demo, it was in Python, but you can also write it in C, in Go. It's really up to you until you are using something that can run on Linux distribution.
Okay, and where the TensorFlow script was launched?
So this is again a good question. So to answer to this question, for this demo and with our event-driven processing today, the script will be launched where the data was uploaded. I mean, this demo, it was a one single node environment, so it was only on one single node. But if you think about a platform with hundreds of nodes or thousands of nodes, it will be launched where the data resides. I mean, where the data will be uploaded. We will launch the script there. So this is the first part of the answer. But as Enrico mentioned, we have a new version that will be released in the coming months, where we will use all the good points from OpenIO, I mean the conscience, and we will be able to say, okay, I have a new file, I want to process and to do something on this new data uploaded, and then we'll ask the conscience, as we are doing today, to use the best node and to perform the task. About the conscience, for those who are not familiar with our conscience system, the conscience is a system that is computing quality score on every disk of the platform. So for the storage side, it computes a quality score for every disk of the platform. So at the end, when you perform an operation on your OpenIO cluster, I mean upload a file, upload or read a file, with this quality score, we ensure that every time you want to perform perform something on the OpenIO cluster, we ensure to use the most available and the best disk of the platform to do it. So what we will do in the coming months is to do the same with the processing framework. It's to choose. For example, if we are talking about processing of videos is taking a lot of CPU, so we will choose the best node of the platform with the where the CPU are less used. We'll use this node to perform the transcoding of the video.
Okay, thank you. One question about the community. Your software is open source. Do you have a community? Can we join the community?
Yes, of course. So we have a community, and you have many ways to talk with the community. So we have a forum on our website, so you can go there and ask questions, and we will find also some interesting finds about OpenIO, some people that are implementing the grid flaps technology for many different use cases. We have also a community Slack, so you can go to slack.openio.io, and we have a Slack where we have our community, so it's an easiest way to chat with the community. We have also, of course, our social network, so you can ask questions on Twitter or so on. And also, of course, you can send us some email, but yes, there are many different ways, and GitHub. Of course, there are many different ways to talk to the community, and also to talk to the OpenIO developers.
Okay, so I think you already answered to the next one. How do you control the load of the apps processing and the load balancing conscience?
So this is a very good question. So again, it will be a feature that we will release. It's not yet available. I mean, this is something that we'll release in the coming months. So what we will do with that, because it's a very good question, because it was something that we are looking for in the coming months and coming years, it's to use a kind of container solution. I mean, we'll be able to say, okay, I want to spread, there is a new video, I want to transcode it, so I will use the conscience, okay, give me the node where the data where the processing will be the faster, and using the constraints we choose this best node, and using the Docker container, we can Docker or whatever container solution will be able to say, okay, you can launch your transcoding here, but please don't use more than one CPU, for example. So this is a way to distribute the load, and also to say that, okay, this processing will not take too much, will not take all the CPUs from one node.
Yeah, I just want, sorry, I want only to add a small thing that by using the container, you will be able also to run distributed applications. Okay, so very complex application, like if you are running a MapReduce or other things, you will benefit from all the cluster. Okay, so that's a real advancement. It's not just a script, but it's a very complex application that you can run on the platform with this new system that we are implementing.
Okay. Regarding your previous answer, Guillaume, so you have the kind of conscience plus that will be able to score the CPU, RAM, load of servers?
Yes, of course. Sorry. So the conscience is already able to do that today. So let me give you more insights and more information about the conscience and how it works. So today, the conscience is collecting metrics on every node of the platform, and you can give to the conscience, you can add your own metrics. I mean, today we are collecting CPU, RAM, capacity, IOs, mostly for the storage side, but you can also upload your own metric inside the conscience. And at the end, how works the conscience is that you can take these metrics and compute your own quality score. You can also configure how the conscience will score a particular specific service inside the solution. So yes, of course, the conscience is able to take, and if it's about processing, it probably be about a CPU. You can say, okay, I want to score these resources, which is processing, an antivirus, a TensorFlow use case, and you can say, okay, for this specific services inside OpenIO, I want only to compute a score with CPU, and I don't care about capacity and so on. So you can really configure and tune the conscience to compute the right score for your services, and you can also add your own metrics to do it.
Okay, thank you. Last one. What about if I have an erasure coded file?
Yeah, again, it's a good question, because I told at the very beginning that we will launch the processing where the data resides. In case of erasure coding, your data will be spread across will be spread on many nodes. So what you will have to do is to use the OpenIO APIs. So when a new file is uploaded, you have an event, and then you can use the OpenIO APIs to retrieve all the blocks of this erasure coded file and object, to rebuild it locally and launch the processing on it on one node.
Thank you, Guillaume. I think we are done for today. If you want to continue the discussion, you can find a lot of information on our website, openio.io. Thanks everyone for your time. Thanks, Guillaume. Thanks, Enrico.
Thank you.
Thank you very much.
Yeah, and the webinar was recorded, so we'll send you all the link to the video if you want to see it again. And yes, again, like I told you, we will publish all the content. So if you want to reproduce it in your own environment, in your own infrastructure, you will be able to do it by yourself.
Yes, exactly. So you can join us, as Guillaume mentioned, you can join us on Slack, slack.openio.io, join us on GitHub, open-io, follow us on Twitter at OpenIO. You will receive the record of the webinar in the next few days. I wish you a very nice day, and I hope to see you next time. Bye-bye.